Welcome to Lesson 25 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to add in some basic error handling to our application. So let's just jump right in. Here we have our tournament viewer form. We just finished working on this a few videos ago. Now we know that in our last video, we said that if a score was tied and we hit score, it'd throw an exception. But let's see that in action first, before we go any further. So let's load up our testing tourney. And here we can see the uncanny losers versus team first place. Let's give them both a score of 1. If I hit score, I get this error message right here. If the user were running this application not in Visual Studio, but actually as the exe, then what would happen is the application would throw an error message and then crash when they close the error message. So that's not good, but notice it says, we do not allow ties in this application. That's my message. That was from when we said throw new exception, we do not allow ties in this application. So at least it passes our information along if we want to use it. So there's a couple things we could do. One, in the code behind for our score button right here, we could say, well, inside here, the score button is where that error happens. What some people will do is take all this code and do a surround with try catch and say, I have error handling. You don't. And you have horrible error handling if you even pretend to say it's error handling. Usually it's more like error eating and no clue why things are having errors, but I'm just going to surround the entire thing with a try catch and hope that fixes the problem. Remember I said that if your application fails in unexpected ways, it should fail spectacularly. If you're not expecting certain data, unless the user gave it to you, and you think it has to be in a certain format and it's not, you should just crash right there. You shouldn't go any further. So I am a big proponent of saying, no, shut the application down. But when we know there may be an issue that is caused by the user, there's things we can do. The first thing you can do is right here is where that error might be thrown. So I could right click on this, just this line, and say surround with, and say try. And that puts this line of code inside the try catch block. And then for exception, here's the other thing people don't do. Let's give it a name. Don't just have exception here, actually give a name. And the reason why is then we can do something with it. Now, note this throw here. What this will do is by default, it will throw the exception or continue to throw the exception after we have completed this try catch. That way, we can catch the exception in multiple spots if we want to. But we're in the user interface, we don't want to catch it. Also note that it's not doing a throw EX. That's bad. Don't do that. Don't put the variable name in afterwards. That actually destroys important information about the exception. So don't do that. But in our case, we're going to catch this exception. And we're just going to say messagebox.show, and we'll say the application had the following error. And we'll say, I have to put my $sign in front of this, ex.message. And we could make that a red X in the for the icon and all the rest, but we're just going to put just the message for now. So now when we run this, let's run again. We'll say testing tourney, load tournament, select our team, our matchup, put 1 for each value, and now it says the application has the following error. We do not allow ties in the application. Now, if I go back to that matchup, it still has the scores, but they aren't saved in the database. And that's pretty good. And I'm going to leave that try catch on there because I do want to catch any kind of errors that come through from saving to the database. But I don't think we should get that far. And this is one of my main tenets of application development is you never trust the user. The user will give you bad information all the time. They really will. So right now we're saying, I trust you, put a number in there. Well, why? Why are we trusting them? We should trust but verify. And so in the score button, before we go any further, I'm going to call a private method. Say if is valid data, that's a method. If it's not is valid data, therefore I'm going to put the exclamation point in front and say message box dot show you need to enter valid data before we can score this matchup. Okay, so this method right here is valid data. We're going to say private bool is valid data. And I'll create an output, a bool output equals, and we'll start it off with true. Normally I'd initialize this to false, but again, it's much easier to set a value to false many times than it is to say, is everything correct? And if so, make it true. So we're going to start off with true, and if anything goes wrong, it will always be flipped to false. Now, what do we need to check? Well, we need to check to see if team1 score value.text is a number, a double, and also the same for team 2. So let's do something very similar to what we did here. We'll create two variables, and then we will do this entry right here, and then we'll do this entry right here. And we'll say, instead of score valid, we'll say score 1 valid and score 2 valid. So now what we're doing is we are grabbing team1 score value.text and team2 score value.text, and we're capturing if these are valid doubles. So now, if score 1 valid, I'm going to say if not score 1 valid, and I'll actually make this really simple by saying or not score 2 valid, then output equals false. Then down below I'm going to say if team1 score equals 0 and team2 score equals 0. That means they're both 0. And why are we scoring something if they're both a 0 value? Can't do that. So output equals false. And then if team1 score equals team2 score. Now we could have collapsed these two into one, because if they're both 0, then they're equal to each other as well. But I like the idea of separating it out because it could log something differently in each of these cases. So we could say for team1 score equals team2 score, output equals false. And then return output. So that would work And now it's going to pass back a true or false. If it's valid, it passes back a true. If it's invalid, it passes back a false. But let's get a little more descriptive. And let's first run this, just to show you it does work. I want to improve it next, but first let's run this. And so here's our team. We're going to say, leave it at 0. You need to enter valid data. Okay. So I'm going to say it's both of them are 1. You need to enter valid data. Okay. And it says, oops, we do not allow ties in this application. That's interesting. So now we have tried and it got through. And the reason why is because we didn't say down here, return. So that was our bad. My bad. So let's run again. And this time we're going to give it something even worse. We're going to say hi and yo. You need to enter valid data. Excellent. So it's not actually doing anything then with these values. And in fact, those values didn't even get stored inside of the model. So that's good, but that message is kind of annoying me. You need to enter valid data before we can score the matchup. That's great, but it's really generic. Why? What's invalid about it? So instead of having this be a bool, let's make it a string. Oops, not string output, return output. And we'll start this string off as an empty string. And then instead of saying false, we'll actually put a message in here that says the score 1 value is not a valid number. Now, why just score 1? Well, I'm actually going to make this into 2 if statements. That way I can say the score 2 value is not a valid number. Down here, I can say you did not enter a score for either team. And then finally, we do not allow ties in this application. I forgot my punctuation up here as well. So now, instead of saying not is valid, we can say, and we should say instead of validate data, or is valid data, we should say validate data. And now we can say validate data string error message equals validate data. And now if error message dot length is greater than 0. So that's my upgrade. So now we're going to capture the message that comes back. If the message is an empty string, we have encountered no errors. If it's not an empty string, then we can, instead of having this, we can actually have a more targeted message. We can say input error, colon, and then have our error. So now we run this. We have a number of options for what could go wrong, and each one gets its own message. We do not allow ties in this application. That's interesting. So let's find out why that is. Well, if you notice, we have Team 1 score and Team 2 score, and those are outputs. But what if we fail one of the outputs? meaning it's not a valid number. Well, it returns a false, but it also sets that value to be 0. Therefore, these two will be equal and they'll both be 0. Therefore, our output message is going to be, we do not allow ties in the application, because these aren't else ifs. These are just ifs. And they don't break afterwards. They don't return afterwards. Therefore, the last one wins. Therefore, we should do either an else if or a return right here. Now, I'm not a huge fan of returning early. I am in JavaScript and not in C#. So what I will do instead is make this line into an else if. And the same for every other line. Now the evaluation is, if score 1, we forgot to take out that or, if score 1's not valid, that's the message, we skip all the rest. If score 2's not valid, that's the message, we skip all the rest. If these two are valid, but they're both 0, that's the message, we skip the last one. If these two aren't 0, but they are valid scores, if they're a tie, that's the message, and we're done. So that should improve our logic. Let's make sure it works. Load tournament. Let's start off with invalid numbers. Score 1 value is not a valid number. All right. We'll make it a valid number, but then score 2 we will make into an invalid number. Score 2 is not a valid number. So we'll make it into a valid number, but they're both zeros. You would not enter a score for either team. All right. Finally, let's add a 2 for each value, and we do not allow ties in this application. Let's make it 2 to 1. Perfect. It works. And now in round 2, the uncanny losers are playing Sue's team. So there our error handling worked. Note that error handling doesn't always mean putting a try-catch block in place. Sometimes it means first checking to make sure the data is valid. That too is error handling. These were errors that it caught, and if it catches the error, it stops the application before it can do any damage. So that's the kind of error handling you need to put in your applications. One where the user has input and they do something. Now, do I need to validate that this is a proper round before I check the list box? Well, no, because it's a closed system. Only valid rounds can be in here. Do I check this list box? No, because again, it's a closed system. The only thing I check for is if it's empty. And while we have to handle empty differently, it's still a valid state for our application. Typing in test in this box is not a valid state for our application. That's an error. We just captured that. But then also where you do have the opportunity to have errors, you can use your try-catch block. Now, this is a very, very simple try-catch block, although it's probably the most common, but you could catch more than one type of exception. So you could say, I know I might get this specific exception, therefore I'll catch that first, and then catch it generically if not. So one place you might want to put our try-catch blocks around, do something with, is whenever we're saving to our text files to make sure those text files exist. The same thing is true for connecting to our SQL database. If the SQL database isn't there, we should tell the user, hey, I can't talk to my database right now, and then not do anything. So that's basic error handling. I'm not going to go through every single place we should put this in the application, because that would just get tedious and repetitive. And really, this is all you need. either have a try catch block and do something with it. In this case, I'm also going to return. That's the one thing I didn't do. So if you have an exception, return. Now in this case, it didn't hurt anything because I'm just loading the matchups. But imagine what would happen if I didn't put this there and then I came back later and added more logic down here. That might be disastrous. Just like I like to have the curly braces for even one line if statements, even though I technically don't have to, I like to have the return statements in our catch block if that's what you should do, instead of just allowing it to continue on to the end, even if it is the end. That way, if you come and put logic in later, you don't have an unexpected result. So, try catch blocks are one way to handle errors. The other way to handle errors is to do some manual validation. And that's also important, and you'll need to do both. And the question may come up, where do I catch these errors? Typically, you catch the errors in the front end. And here's why. What are you going to do with the error when you catch it? You'll probably tell the user something went wrong. Well, where do you tell the user about stuff? In the user interface. Therefore, that's where most error handling goes. We allow it to bubble up through all of our class library methods until it gets to a user interface. Now, there are exceptions to that rule if you're going to catch the error and do something because it found the error. For example, maybe you have a fallback where you save a SQL all the time, but if SQL is not available, that exception gets thrown, and you change the database type to be text file. Well, that could work. So that might be a time when you'd have that in the actual class library. But for the most part, you have exception handling and validation in the front end. Now, validation also goes in the back end. Because just like we don't trust our users, the back end probably shouldn't trust the front end. Because who knows who built it? Especially if you say, well, we're going to take this and make this into an API that a web page can call. Well, now you're trusting a web page to do the right thing? I don't think so. So when people ask me, where do I put this error handling? I say, for validation, throughout the entire application. For error handling, it really depends on specifically what you're trying to catch. Don't just do blanket try catches. It's inefficient and it really hides stuff. All right, so that's all there is to error handling. I don't want to belabor this point. I just want to point out ways we could improve our application through error handling and checking user input. All right, in our next video, we're actually going to wire up emailing the user when it's their turn in the tournament. So stick around for that.